section 4 we're looking at here. And you're going to deal, you're looking at a lot of different relationships with our trig ratios. And you want to become pretty familiar with them. There is a one-page kind of a summary of the majority of our identities on the website. You can go ahead and print them out. It looks like this. Okay, so this worksheet says table of trig identities. You can get that off the web page. So these are called the reciprocal identities. Reciprocal identities. Cosecant x is 1 over sine x. Secant x, 1 over cos. Cotangent is 1 over tangent. They are the oh yeah. They are the little, what we call the little 3 trig ratios. Okay, the little 3 trig ratios. So you can say cotangent, if it's equal to 1 over the tangent, and tangent is sine over cosine, we can say, since tangent is sine over cosine, 1 over sine over cos becomes cos over sine. So the cotangent could also be cosine over sine. Another way to think about it. You want to have as many ways to look at these trig functions as you can. Tangent is sine over cosine. Cotangent is 1 over tangent or cos over sine. You never know which one you're going to need. So you never know whether you need these or whether you need to use one of the others for cotangent or tangent. These are the little 3, and then just a different way to look at it. What you're going to be looking at here, they're puzzles. Sunday mornings, comics, sports, grade section, that's about me in the paper. I'm not a big newspaper guy. I like to do the puzzles. I like, I don't have one up here. I like the little manipulative puzzles. Slide Lock Fox, sometimes they're good, sometimes they're not good. What are you going to do here? How are we going to figure out who has the phone? What could we do? Slide Lock, what would you do? Yeah, that's a good idea. See which one, who has the ringing phone in their pocket. This is another good one. Okay? And it's not good enough to just find the 5 differences. It's not good enough, or 6 differences. It's not good enough to realize, hey, the picture frames, yeah, they moved one of them, didn't they? All right? It's not about finding them. It's about finding them the fastest. So on Sunday mornings, you make it a competition. Who can do it faster? The faster you can do it, the better. If you can't find them all, well, that means you've got work to do on your observation skills. Because there's always 6. You need to find them. Oh, really? We really want to do this? What do we have for differences? The picture frames.
Bubbles and the fish fins.
So the puddle here is different. The chair leg is different.
Oh, it's out.
The tail on the dog. The pictures. What else do we not have? The fin on which fish? The flying fish. Okay, so you're missing the fin. The bubble. There was a bubble issue. Missing a bubble. Okay, so that's 6, right?
Yeah, that's 6.
Right? So my point in this is you want to keep doing things like this because it makes you sharper. It makes your thinking skills and observation skills sharper. Yeah, is it rocket science? Not about that. It's how fast can you do it? How fast can you come up with a solution? And the more you practice, the better you get at it. So here's a series of identities with negatives. And some of them you might know, some of them you might not. Now, remember, if this is theta, and I kind of drew the picture here, I just drew theta. We call the positive angle in quadrant 1 the reference theta. Then the angle in quadrant 4, if it's acute, this is your negative theta. If you were in quadrant 2, your negative theta would be in quadrant 3. All right? Doesn't really matter. I just want you to realize positive theta goes counterclockwise, negative theta goes clockwise from horizontal right. So for sine, all we're looking at, just think about all students take calculus. The sine of negative theta, the sine of the angle in quadrant 4 is the opposite of the reference theta's sine. And you can generate these identities pretty easily as long as you understand how this works with theta and negative theta. If it's true with sine, it's got to be true for cosecant because they're reciprocal ratios. Quadrant 1 or in quadrant 4, when you talk about cosine, what do you know about the cosine in quadrant 1 and 4? Positive, both the same. So cosine of negative theta will be the same as the cosine of the reference theta. Which means if it's true for cosine, it's got to be true for secant. In tangent, we know quadrant 1 and quadrant 4, the relationship between the tangents is they're opposites. So tangent of negative theta is the opposite of tan theta. And that will also be true for cotangent. The big three and their partners, they each work independently, so I did them in different colors so you could see. Those are identities. You want to know those because if you have to generate them all the time, boom, 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 it's not going to be boom, boom, boom. It's going to be slow. And you're going to have a hard time making the observations. Any questions on any of these? Blue, green, or reddish brown? Everybody good? Okay, these three are called the Pythagorean identities. The Pythagorean relationships. Sine squared plus cos squared equals 1. That one we've talked about a little bit before. When you think about putting that triangle in quadrant 1, for example, on the unit circle, the coordinates of the point are cosine, comma sine. This is theta. So this is the cosine of theta. This is the sine of theta. And in the unit circle, the radius is 1. So the Pythagorean identity is cos squared plus sine squared equals 1. Cos squared theta, sine squared theta is equal to 1. We're going to come back to this one in a second, but for right now, let's just leave it like that. The second one, the green one, 1 plus tangent squared is equal to secant squared. Where does that come from? And let me show you. I took sine squared plus cos squared equals 1. It's an equation. I can add stuff as long as I do it on both sides. I can subtract, I can divide, I can multiply. I'm going to multiply or divide, each term by sine squared theta on both sides. How does this simplify? 1. What's cos squared over sine squared? Tangent squared theta. And 1 over sine squared theta, cosecant squared theta. Right? 1 plus cotangent squared is cosecant squared, blue one. How do we get it? We take the first function, the original Pythagorean identity, divide by sine squared. Did I go too fast? Nate, you lost?
Yeah, I'm trying to figure out how you got the green one. It's just divide cosine, right?
Correct. So we can take that and divide everybody by cos squared. Cos squared theta and cos squared theta. What's sine squared over cos squared? Tan squared. Cos squared over cos squared, 1. And 1 over cos squared?
Secant.
Secant squared theta. So in this case, sometimes, it's not really ridiculously difficult to come up with these two functions, the green and the blue, simply by taking the original one and dividing by sine squared or cos squared. But you want to know each of them. And you also want to be able to manipulate them. So for example, this green, bless you, the green identity, 1 plus tan squared equals secant squared, what else is true if this is true? In the most obvious way. What else would be true if this is true?
Secant squared.
Okay, so tangent squared theta would equal secant squared theta minus 1. What else would be true? It wouldn't be equal to 1, it would be equal to -1, but let's not use that one necessarily, although that's not a bad one to have. But from here, that's a two-step transformation. Secant squared minus tangent squared. Okay. And then you could start multiplying by -1 and switching things around and so forth. Same thing is true in blue, same thing is true in red. The idea behind this is if you see secant squared minus tan squared in a problem, and you're simplifying, you replace it with 1. If you see 1 plus tangent squared, you replace it with secant squared. If you see cosecant squared minus cotangent squared, you replace it with 1. If you see cosecant squared minus 1, you replace it with cotangent squared. You want to be able to manipulate them. I know how this works. There's nothing complicated, but the only way you'll be able to do this is to memorize it. Think about your statement going into the last test. Oh, I didn't really study. I hope I do okay. In this one, if you go into this test without really studying, you better be hoping you can cheat really well, because you will not have a chance on this test. I don't recall. There's a lot of no calculator stuff on here. A calculator isn't going to help you with these.
Oh, I know.
You know, but
I was just.
I honestly don't remember, but a calculator for this stuff doesn't help at all. And you'll see what I'm talking about in a minute. We'll do some of these problems for you. Michelle, good? Everybody good here? These are called co-function relationships. It means you're doing one function in terms of another. We alluded to some of this yesterday when we talked about the sine and cosine graphs being 1/4 of a period off. So that the sine of theta is equal to cos 90 minus theta. And the cosine of theta would be the sine of 90 minus theta. And similar values for tangent, cotangent, secant, and cosecant. So I'll give you a second to get these ones copied if you want them. So if we're going to simplify this, how would sine of b divided by tangent of b, how could you simplify that? How would the sine of b over tangent of b simplify? Yeah. Okay. Put that down. Sine. The sine of b over the tangent of b. What's another way to write tangent of b? Sine over cosine, right? So that becomes the sine of b times the cosine of b over the sine of b. What happens here? The sines cancel. So again, sine of b really over tangent of b equals cos b. See that? See what we did here? Good thinking, right? In math class, you gotta reach for what we can get when we can get it, right? Really? Fractions are going to kill in this chapter, I can tell. I can't add fractions, I can't subtract fractions, and I can't divide them. What am I going to do? Oh, better learn quick, because you're about to get run over by the truck. All right? Honestly, it's not the identities that cause the problems, it's the fact that we can't add, subtract, multiply, and divide fractions. So here's an example. We're going to simplify the secant of x minus sine x tan x. And there's a whole bunch of options on what you can do to simplify this, but it's one of those things where I can't say, oh, every problem this is what you do. It's not going to work for every problem. Doesn't work for every problem, but you do need to be able to simplify. One of the things that is a useful tool is when you have all these trig ratios, get everything in terms of sine and cosine. So how could I rewrite secant? 1 over cos x. Sine x. What about tangent of x? Sine x over cos x. Again, I am not telling you this works every time. I'm not telling you it works this time. I'm just saying we're going to take a look at this and see what happens. So 1 over cos x minus, what's sine x times sine x over cos x? Sine squared x over cos x. You don't put the squared out here. You don't put the squared on the x. You put it in between the x and the function. Otherwise, it looks like you're squaring the angle. We don't want it to look that way. How can I combine these? 1 minus sine squared x over cos x. What's 1 minus sine squared? Cosine squared x over cos x. Leaves us with cosine x. Oh, what was that? Oh, holy moly! One minus sine squared is cosine squared. You're at the mercy of what you know. If you try to fake it, it blows up bad. Remember, this starts off with sine squared x plus cos squared x equals 1. And when you subtract sine squared, this is what we're replacing with cos squared x.
Do you always use the sine squared x plus cos squared x to 1? That's not the main.
When you use the a word like that, I can tell you right now, no. Always. There are no always.
Well, okay, I mean, like, is that one of the main identities?
Well, again,
Or what are the other identities?
well, let me show them to you.
There's only like 3.
We got these.
Yeah, not those ones.
We got these.
Yeah, those ones.
So all of these Pythagorean identities in any form That's what I'm telling you. You've got to manipulate these to use them.
Yeah.
You got these, and
Because
of course.
this will be the fourth quadrant right here.
So
Sinus always has
tomorrow I'm going to give you a whole nother pile.
a negative.
It is fantastic. It's a beautiful thing.
It's the same thing as negative.
My point is, Megan, you need to learn as you go. You've got to study these to get them dialed. And I don't really expect everyone's going to walk in tomorrow and everyone's going to say, okay, I got them, let's have some more. But the reality is, if you wait, it's going to be really bad. The 9 days off is a nightmare for this chapter. So I'm telling you what's going to happen. In 9 days' time, you'll come back and you'll all laugh on that Monday night when you haven't touched your pre-calc stuff for 9 days, 10 days. And you'll go, holy crap, am I in trouble? I know we did this thing with sine and cosine and sin and cause, and I remember the Cosby thing, that was funny. And sinning, we just finished the Easter deal, so I know about going to hell. They were done with Lent, thank goodness. If you wait, you will really eat it on this chapter, and it's really easy, as long as you know your identity. Could be.
That is. One in graph.
Everybody okay with this example? Now, the directions for this one, are to simplify this expression. The directions are to simplify. This is another one, simplify. See what you can do with it. All right, what does secant become? Sine theta times 1 over cos theta. What does cotangent become?
All the factors.
Yeah,
What does it simplify to?
1.
You gotta really feel like you're done when you get to something like
I don't
that.
think we're done.
You shouldn't be going, gosh, I wonder if we could go, let's change it to sine squared
Yeah.
plus cos squared. Okay, that's not making it simpler. 1 is good. Right? Is that the same one?
Yeah, I went 1.
Yeah, that's weird. All right, try this one.
1. The same thing.
First thing you might consider. Okay, so cosecant theta is. So 1 over sine theta times cos squared theta cubed theta, and then change tangent to what? Sine theta over cos theta minus sine theta, right? 1 over sine theta, cos cubed over cos. Cos squared theta sine theta minus sine theta. What's in common in the parentheses?
Sine theta.
Sine theta. So you could either distribute or factor. Doesn't matter to me. If you distribute, you get cos squared theta minus 1, which is negative sine squared theta.
How did you use sine squared theta? I'm not good at cos squared.
It's an identity.
Where's the 1 over sine theta?
Cos
Yeah,
squared
like just write it out.
plus sine squared equals 1.
Yeah.
Cos squared minus 1 equals negative sine squared.
Oh.
If you subtract sine squared and subtract 1. Hey, if you subtract sine squared, you subtract 1, you get this equation.
Yeah.
That means anywhere you see this, you can replace it with this.
It's like you can't use the infinite buffer.
One more
You
time.
can't use the cosine squared theta minus 1.
I did. Cosine
No,
squared theta minus 1 is equal to,
That can't be your answer.
in most simplified form? No, because cos squared minus 1 is equal to negative sine squared. Great job, but not done. And again, this is an intuiting thing. You want to intuit and say, hey, we have an identity that sine squared plus cos squared equals 1. I got 2 of those pieces. There's got to be a way I could write it in terms of the third. Not always true, but in this case it is.
So sometimes that would be the one.
Sometimes you couldn't, there's nothing you could do. Okay? Like if it was cos squared plus 1, there's nothing you could do with that. Re-explain.
Yeah, we just froze everything.
Underwear. Well, look, I said underwear. When you're going like this, I have no idea what you're talking about. You can't tell me what it is?
Here or sit?
Yes, just pretend we're working right here.
Okay.
Okay? You pretending?
Yeah, I don't even see where you go.
That came from here.
Oh,
Sine squared plus cos squared equals 1. I memorized it. You'll memorize it too. You don't want to be in huge pain and suffering. So all I did was write it here. Is that okay? We're going to do cos squared is equal to 1 minus sine squared. Do that? Sure. If I subtract 1 on both sides, I'd have cos squared minus 1 equals negative sine squared. There's that. Here is cos squared minus 1. Cos squared minus 1. What's it equal to? Negative sine squared. So are you not sure where this came from?
yeah, I don't see how it goes.
Okay, let's distribute. Cos squared sine divided by sine, what cancels? What would you have left? No. Right? Or no? I'll put another line in here if you're not seeing it. Okay? When we multiply this times this, you're going to get cos squared theta, sine theta, over sine theta. You agree with that? Minus sine theta, over sine theta. You agree with that? Here, cancel, cancel, cos squared, cancel, cancel, 1. Sure. Does that make sense? This, you have to kind of get a feeling, what the heck? Yeah, right there's good. Take that speed. You gotta get this feeling, what the heck? I know cos squared and 1 is an identity.
Are you really?
Get to this point on your own.
Just look downstairs.
You don't want to have to memorize every iteration of every identity. But you want to intuit and say, okay, you want to intuit when you see this as being something that might have come from here. So can I manipulate this so that one side looks like this? The answer on this case was yes. But if it was a cos squared plus 1, this is a plus sign, that would fall apart. Okay? Everybody good on this one? Notice the directions just changed. Proof. So they're already telling you, hey, when you're done simplifying, this is what you should get. The general rule for this, when you have an equation, is to try not to touch both sides. Try not to change both sides. Pick a side and work on that side to try to make it look like the other side. In other words, this cosecant squared A, you're probably better off leaving that alone and just trying to get the left side to look like a cosecant squared. Again, there's a lot of options on how to handle this. When you're dividing by the tangent of A, you may want to switch cotangent and tangent to sines and cosines. That might be helpful. So if we switch cotangent, what does that become? Cosine A over sine A. And 1 plus tangent squared, secant squared A, over sine A over cos A. If you're dividing, and we want it to equal, and we leave the right-hand side alone. If you're dividing by sine A over cos A, that's the same as multiplying by cos A over sine A. Cos A over sine A times cos A over sine A would give you cos squared A over sine squared A times 1 over cos squared A. What cross cancels? Cos squared A. So this cancels with this, leaving us with 1 over sine squared A. And 1 over sine squared A is cosecant squared A. Equals cosecant squared A, and we're done. That's what secant squared is. So I changed secant to 1 over cos squared. At the same time, I multiplied by the reciprocal. You got cos squared over sine squared. Again, you can show more steps in here, but this is the most direct route. It's predicated on your ability to multiply, divide, add, and subtract fractions. Obviously, the identities play a part, but the inability to manipulate the fractions is the killer. Any questions on that one? I'm sure there's other ways to do it. Don't feel like, gosh, I didn't do it the way he did it. I don't care.
I separated their first red part, and I got 1 over cosine of A, and then all of that over sine A over cosine A. And then, like, I did the reciprocal and multiplied 1 over cosine of A times cosine of A over sine of A.
How'd you get 1 over cosine of A?
The secant squared A.
Oh.
Let's do 1 over cosine squared.
All right. Anybody else? Okay, here's another one. If you can handle this one, again, don't feel like there's only one way to do it. So if you're going to finish this, your common denominator is going to be the product of your 2 denominators. Now, how much you need to show varies. 1 plus secant of A over 1 minus secant squared A plus 1 minus secant of A over 1 minus secant squared A. Now we have the common denominators. The 1 minus secant squared is what you get when you multiply A minus B times A plus B here. Difference of 2 squared. When you add the tops, you get 2 over 1 minus secant squared A. 1 minus secant squared A is negative tan squared A. And this can be simplified, if you want, to negative 2 over tan squared A. 1 with tan squared A on the bottom, that's 1 over tan squared A. That's the same as cotangent squared. So that checks. Are there other ways to do it? Probably. Don't feel like there's only one way to go. This is the assignment here. If you haven't finished off 8.4, I think we're on this one here, right?
No, we
No, we're on 8.4, we're on 8.4.
Okay, then this is 8.4 right here.